How does switch work? On our latest videos, Introduction to IP World, we have found that bits are language of machine, how packets traverse the network, and that whole logic is organized thanks to Internet Protocol. We know that networks consist of network devices and end devices which produces symbols that we call bits and form them into packets. We have also learned what is router and how does it work. To allow communication between billions of devices, network devices are needed. As we know from the How Router Works video, routers like crossroads and road signs properly direct packets from source to destination. They look into the packet searching for destination IP address. Source and destination IP are included in packet header. So far so good. Now we need to have some devices that allows us to connect high amount of users and wired devices together. This is something that routers are not intended, because routers in most situations has limited number of ports, operate with more advanced features, and they are more expensive. Let's imagine that we need to connect small home network with router to internet provider and 4 laptops. Not possible because of not enough ports. That's why we need switches. But not only port density and the cost is the domain of switches, but also the way they work. Ethernet switches don't understand IP packets but frames. As an IP packet is language of router, frame is language of switch. What is the purpose of frame? Let's assume local cable network, that is a type of network access. We have nowadays 2 basic types of how user access the network: wireless medium, Wi-Fi, and wired Ethernet medium. We often call it cable, wired, or finally Ethernet. Ethernet describes many technical parameters of how devices can access the network, how cables should look, what speed the transmission can achieve, and finally how the bits and addresses are organized. As we remember, every device produces packets and they are forwarded across the network, regardless of network access type. Every access type uses its own structure to forward data in its environment. Ethernet uses structure called Ethernet frame. To transport IP packet through the Ethernet environment, device adds extra bits to the front and back of the IP packet, making the frame. This adding process is called encapsulation. Every device has a hard-coded address called simply MAC address. If a computer sends the packet to another device, encapsulates the packet with frame using destination MAC address of device B and own MAC address as source, then sends it out. Frame arrives to B. It is stripped and packet is interpreted. Knowing what is the Ethernet frame, let's go back to switching process. To connect more than 2 devices together, we need more ports, so we need switch. Device A sends frame out again with the same destination and source MAC address. This doesn't change, but when a frame arrives at switch, the switch needs to direct the frame out the right port. This direction is called switching. Let's concentrate on switching operation, the primary role of switch. When frame comes into the switch port, switch needs to decide which ports to switch out the frame. Then consult the table in memory which stores port and MAC address pairs. Switch didn't know which port to use to forward the frame. Important to remember, switch doesn't look into the IP packet. It forwards frame as is. But how does the switch build the table? Switch learns the MAC and port pairs in the process called MAC learning. When the frame arrives, the switch checks the source MAC address from frame and stores it next to port number on which it was received. This process builds the table. And what about these destination MACs that are not known for the switch yet? In our picture, device B is not known for switch yet. If frame directed to the B MAC arrives on interface, switch console the table, and if doesn't find the MAC, multiplicates the frame, sending it out all ports except the one it was received on. All the devices that the frame was not intended for drop the frame, and only B device will interpret this. After device B will send back the frames to device A, switch will learn the device B MAC and will store in the table and will forward the frame directly to device A without having to multiply, because it has the MAC and port already. Now you can imagine that if you want to send IP packets across the network to computer B, it's very likely it has to pass several network segments, some connected with Ethernet and some with Wi-Fi. Every network segment will use different access method, so different frame. Device A sending packet access network with Ethernet encapsulating IP packet with Ethernet frame. Then the switch switches the frame to the next device, which is router. As we know, router looks into IP, so needs to strip the frame to look into the IP address included in packet. After choosing right port to route the packet, again encapsulates packet with frame. Wi-Fi frame comes to device B, and this device interprets the packet. To learn about the routers, watch our previous video How does router work? To watch about the data transmission technologies, watch the Introduction to Data Transmission track. Thanks for watching.